Hey everyone, this is dividing radicals, and this is the type of dividing where we are going to do something called multiplying by the conjugate. For all of these, we do not have, we do have a radical in the denominator, and it's not proper for us to have our answers with a radical in the denominator. So we are going to show you how to do that. They all look like fractions because fractions are really just little division problems. So this is dividing, although it just looks like little fractions, and we're going to multiply by the conjugate. So I need to tell you what a conjugate is. A conjugate, the best way to show you what a conjugate is would be to give you an example. Let's say you had a plus the square root of b, where a and b are both integers. This is the most general form of a conjugate. The conjugate for this would just be a minus the square root of b. So in short, a conjugate is just the same thing, only with the opposite sign in the middle. Only in the middle. That's all you have to change. And so to do these little division problems, we're going to be multiplying by the conjugate of the denominator. So you always want to remember, when you do these, you're multiplying by the conjugate of the bottom part. Okay? It's okay to have a radical in the numerator. We just can't have one in the denominator. So let's get started with the first example. To do this, we look at the denominator and we decide what the conjugate's going to be. So this has a minus sign in the middle. So since it has a minus in the middle, the conjugate of that is going to be 4 plus the square root of 3. So we're going to multiply by 4 plus the square root of 3, and whatever we do to the bottom, we're also going to do to the top. Keep it balanced. So now this just really becomes a multiplication problem. We're going to multiply across the top, and we're also going to multiply across the bottom. So let's do the top. This is just distributive property. So 7 times 4 is 28. And then 7 times the square root of 3 is plus 7 root 3. All over the bottom part. 4 times 4, which is 16. 4 times root 3, which is 4 root 3. And then 4 times negative root 3 is negative 4 root 3. And then negative root 3 times positive root 3 is negative root 9. So an interesting thing that's going to happen every single time you multiply by the conjugate is you're going to have terms in the denominator that are going to cancel each other out. So this is going to go and that's going to go. Now we can break down the square root of 9, which is 3 and 3, or you may just remember square root of 9 is 3. So the denominator of this is going to be 16 minus 3. And that can simplify to 13. Now we don't have a radical in the denominator, so that's good. We're in good shape. The top, we're going to look to see if that can be simplified at all. I don't believe we can break this down any further, so our answer will be 28 plus 7 root 3 all over 13. And that's a perfectly good answer in simplest radical form. That's how you do division. So let's do the next example. I'm going to recopy it so it's a little bit bigger. So I'm going to do root 6 over 5 plus the square root of 3. So to do this, we're going to multiply by the conjugate of the denominator. So the conjugate would be 5, got to do the opposite of this sign, so minus root 3. We're going to do it on the bottom and on the top. I'm going to put parentheses around this. Okay, so now we're going to multiply across the top and multiply across the bottom. So root 6 times 5 is 5 root 6. And then root 6 times root 3 is minus root 18 over 5 times 5, 25, 5 times negative root 3, negative 5 root 3, root 3 times 5, positive 5 root 3, and root 3 times negative root 3 is negative root 9. So notice what happened in the middle. You got a negative 5 root 3 and you have a positive 5 root 3. So those are going to go. They cancel. We know the square root of 9 is 3. And so this is going to be 25 minus 3, which is really just 22. Now, the numerator, can we break this down? Well, I don't think we can break down the 5 root 6, so that's just going to be right in the front there. But this square root of 18, I think that we could break that down. So if we break down the square root of 18, that would be 9 times 2. And then 9 would be 3 and 3. Take out a group of 2, so we've got minus, because that was minus, 3, and then left over in the root, square root of 2. Feel free at any time to pause the video if this is going too fast. Alright, one more example. Let's try this one. You have 1 plus root 3 in the denominator. Remember, we only care about the conjugate of the denominator. So we're going to multiply by 1 minus the square root of 3 on the top and the bottom. Okay, so we got to FOIL the top and FOIL the bottom. So we're going to be real careful with this one. So negative 2 times 1 is negative 2. Negative 2 times negative root 3 is positive 2 root 3. Remember, this is an outside number. This is an inside the radical number. So we can't multiply those. It just gets written like this. Okay, now we'll do this one. Negative root 3 times 1 is negative root 3. Negative root 3 times negative root 3 is positive root 9. Draw a line. We'll take care of this in a little bit. Let's multiply the bottom. 1 times 1 is 1. 1 times negative root 3 is negative root 3. Root 3 times 1 is positive root 3. And then positive root 3 times negative root 3 is negative root 9. Okay? So look, it happened again. Those go. The square root of 9, which conveniently we just keep having in these examples. It's not always the square root of 9 at the end. It just happened to work out for these. That comes out to be a whole number. It's a negative 3 because that's a minus right there. So 1 minus 3 is in your denominator because there's a 1 right here, which is negative 2. So let's see. We got like radicals right here. So we can combine those. What is 2 root 3 minus root 3? That's going to be 1 root 3, or just root 3. And then we know the square root of 9 is 3. That's plus 3. Negative 2 plus 3 is 1. And you can write the 1 in the front, like you can write it root 3 plus 1 over negative 2, or 1 plus root 3 over negative 2. Commutative property says either one of these is perfectly fine. Okay, so that's dividing radicals. Try your practice problems. See if you have any questions for me. Thanks!